Production authorized versus qualified. When it comes to lockout procedures, it's important to be aware of the difference between a production authorized individual versus a qualified individual. A qualified team member is someone who has demonstrated skills and knowledge related to the construction, operation, and installation of electrical equipment who has received safety training to identify and avoid the hazards involved. Qualified team members must remain aware of TESS, or the Toyota Electrical Safety Standard. If work on an energized electrical circuit is required, this can only be performed by a qualified person. Not all individuals who are authorized to perform lockout can also perform qualified work. Authorized team members may still require a qualified electrical person to put equipment in electrically safe work conditions. Authorized persons may not participate in a lockout or ACM event where they have not received training on the specific energies and methods of control. For example, an authorized person can operate a disconnect if trained on the operation and hazards associated with the specific device or devices. However, if verification of energy present is using a voltmeter, verification can only be done by a qualified person. So, what can you do as an authorized team member? As an authorized person, you will be trained on the specific lockout procedures for machines within your responsibility. The purpose of this lockout training is to inform you of minimum requirements for when to lock out an energy control device before performing service or maintenance on equipment. Lockout is not the act of simply attaching a lock to a device. It is a carefully developed multi-step process designed to safely isolate hazardous energy from a system or machine. The 8 steps of lockout. In order to safely perform a lockout procedure, you must follow all 8 steps. Step 1. Confirm placard and prepare for shutdown. Step 2. Shut down the machine or equipment. Step 3. De-energize, isolate the machine or equipment. Step 4. Apply lockout devices. Step 5. Release residual and stored energy. Step 6. Verify that the energy is isolated and controlled. Step 7. Clear the area once work is complete. Step 8. Notify, then remove the lock and re-energize. If all 8 steps are followed in order and properly executed as part of an approved procedure, the risk of unexpected startup has been mitigated. Please note that performing work itself and the steps involved is not a part of the lockout procedure. Work jobs may require additional steps and requirements. Step 1. Confirm placard and prepare for shutdown. Start by determining what energy is present. Read and confirm the procedures for the equipment involved. Identify the type and magnitude of energy. Understand the correct method of control. Once you sufficiently determine what energy is present, it's time to analyze hazards and review protocol. Understand what hazards you may encounter. Know the operation of the machine you are working with. If a hazard is encountered, review documentation. To prepare for shutdown, you should familiarize yourself with written procedures. Understand what steps are required to perform a safe shutdown and follow them. When the equipment is safely powered down, you must notify all affected employees. If you are not sure about the energy or magnitude of energy present, the control methods prescribed, unclear steps, missing steps, or unfamiliar procedures, do not proceed. Instead, you must stop, call, wait. Step 2. Machine or equipment shutdown. When it's time to power down a machine or equipment as part of lockout, the operator or authorized individual is responsible for 1. Following isolation placard. This may involve shutting down or turning off the machine in an orderly fashion, or using the specific established procedures for each machine and/or equipment. And 2. Ensuring that the authorized individual is trained in performing this procedure. Management is responsible for providing training when appropriate. It's essential that you always know the proper shutdown procedure. Step 3. De-energize, isolate the machine or equipment. After the equipment has been shut down, start isolating or de-energizing the machine or equipment. All energy isolating devices previously identified during the preparation step should be operated to properly isolate the machine, equipment, or system from the energy sources. When you have identified the devices that need to be de-energized, you must release all residual energy. Some of the processes involved in this step are relieve, block, blind, and bleed. Depending on the scenario, additional processes may be required. When reacclimation is possible, a method of monitoring confirmation is continuous. The isolation procedure must be followed exactly as prescribed to guarantee the equipment or machine is properly de-energized. Step 4. Apply lockout devices. Once the equipment is isolated, you must apply locks. Remember, only authorized persons are permitted to apply lockout devices. All individuals who are working on, inspecting, or are otherwise exposed to the hazardous energy of the equipment will each apply his or her own safety lock with an identification tag. If you are installing a lock, you must remove and control your unique key to any locks at all times. Each person involved with the equipment must confirm the security of the safety lock, while ensuring the integrity of all attachment points and hasps. When doing so, make note of any damage and wear that may impact how effective the lock is. Step 5. Address residual energy. During Step 5, all residual or stored energies must be bled, released, or relieved. If you encounter an isolation placard, it will list all forms of residual or stored energy and the correct method of control, dissipation, blocking, bleeding, and other relief tactics. In the case of electrical lockouts, be aware of the following sources of stored or residual energy: accepted circuits, batteries, capacitors, shock, arc flash, thermal heat, and unexpected motion. In the case of fluid power lockouts, be aware of the following sources of stored or residual energy: trapped fluid power, unexpected motion, high pressure laceration, or spray ejecta foreign. And always remember, testing on electrical circuits or components shall be performed only by electrically qualified persons. Step 6. Verification of isolation and control. Although your energy isolation device has a lock attached, you have not yet achieved lockout. In order to fully achieve lockout, you must verify that the lockout devices are effectively acting as energy control measures. To do so, you will need to test the machine or system using specific provided requirements. These requirements are part of the placarding or procedure. For example, fluid power scenarios: observe gauge pressure drops from the system to zero. Listen for air release or exhaust during valve operation. Gravity scenario: confirm the load or moving part rests on the ground surface. Alternate gravity scenario: confirm part is in the fully up or down position according to structure and movement. Spring: tension or compression is removed or bled off, etc. System: attempt to operate controls including up and down, advancing and returning, etc. No motion or movement should occur. Electrical: attempt to operate controls. When you are finished testing, return all controls to a neutral or safe position for startup. Unqualified individuals may have a qualified electrical person de-energize the circuits to create an electrically safe work condition. Remember what you are qualified to perform and what you are not to maintain a safe de-energizing process. Work, service, or maintenance. The actual service and maintenance of the machine or system is not a step in the control of hazardous energy process. Once all of the procedural steps for the controls of hazardous energy have been completed, including the verification of isolation and the effectiveness of the controls, you may begin service and maintenance upon the machine or system. You may only work on the machine after you have confirmed zero energy. Step 7. Clear the work area once work is complete. Once the work is completed and before you remove your lock, the work area needs to be cleared. Follow these steps when clearing the work area. Ensure all affected personnel and others are not in the danger zone. Remove all tools and/or materials brought into the area. Use checklists where necessary. Confirm all guards and other similar pieces of equipment that have been removed are properly reinstalled. Confirm the equipment is in a proper startup attitude or condition, such as ensuring the controls are neutral. After you have completed all of these steps, you are permitted to remove your safety lock. Never remove or disturb another person's lock. Step 8. Notify affected individuals, remove the lock, and re-energize. Start by notifying all affected individuals of intent to restart. You must do this before you remove your lock. After you have notified all relevant parties, you may remove your lock. Once the lock is removed, confirm the controls are neutral, then re-energize the equipment. Keep in mind that if you are operating an electrical disconnect device, there are specific safety precautions you need to follow, such as left-hand rule. In addition, remember to close the disconnect firmly and decisively to minimize risk. If the device does not want to operate smoothly, or if you notice anything unusual such as binding or resistance, stop, call, wait.